Hi, I'm Doug Britton, Training Manager at Prominent Fluid Controls. Today we're going to, in this video, step through each individual menu in the Nude Gamma X pump. I'm also going to show you the outward physical appearances, what some of these plugs down here are for. We'll talk about all the menus, all the buttons, all the features. That way, hopefully this will make you a little more comfortable when you're out there trying to set these pumps up. Starting off, we'll talk about what's going on just in front of us here right now. You can see we have our main screen display LCD here. We have 4 buttons here, and we have a knob here that we'll further discuss in this video. Down here we have 4 ports. They come covered. They're pretty easy to just turn off. Your first port is going to be for a diaphragm rupture sensor. That sensor would plug into the back of the pump. Right here it's going to plug into this. This would spin out. You would have a sensor that plugged in there. It would run to the front of the pump and plug in here. What that sensor is going to do for you is if you have a ruptured diaphragm, that sensor will signal the pump letting you know that there has been a rupture. It will come, that signal will be sent to the front of the pump into this port, and then within the menus of the pump I can have that either shut the pump off, or I can have it continue to run but give me a warning, which would be a yellow light. This light in the middle, which isn't currently lit, would lit up. The pump would continue to pump, but if I had a relay output like this pump does here, we would be able to send that out to that signal out to somebody, and they will be able to come down and address that issue. Your next port is going to be a universal control cable. If you're familiar with all of our other pumps, the Gamma L, the Sigma, the Delta series, that is the same cable, that 5-wire orange cable. That's going to be how we get all of our inputs to the pump, whether that be our remote pause, that be an analog signal, a contact signal, or our auxiliary signal. They would all be sent in via this port, and that is just input signals. To the right of that, you have the metering monitor. That would be our metering monitor that would sit directly on the discharge of our valve. That metering monitor tells us we have flow. It doesn't tell us exactly how much flow we have. It's just going to tell us if we have enough to register past that read switch that is in that metering monitor that we sell. Lastly, all the way to the right, you have a 2-stage level switch. We could sit this pump directly on top of a drum, and that level switch would drop down into the drum, and that would let us know when we are out of chemical. It is a 2-stage level switch, so it tells us the first stage would be a warning, which would ignite the middle light, the amber light. That would tell us it's a warning that we're getting low, and then the red light would turn on when we hit that second bottom stage, telling us, hey, we're completely out of chemical. Down here at the bottom, my pump is equipped with a relay. I believe this one gives me a fault indicating relay and also a milliamp output. These relays are retrofittable, so if I order a pump without a relay, there would be an orange cover on here. There's a nice gasketed seal behind this. So if I order the pump without a relay, I decide I want to add one in the field, I can just order a kit from us directly, and then it's plug and play. We'll go through the menus. You do have to set up these relays. You have to tell them what you want it to actually do. So we will go through those menus and make sure that when you get the pump, you should make sure your relays are set up prior to the final commissioning of the pump. I'm going to move the pump closer here, and we'll start talking about the screen, what we see on the screen, and how the buttons work here. So talking about the main screen, we have 3 different bars up here. We have our main display. Right now you can see I'm displaying the pump is set up to do 200 strokes per minute. That is the maximum frequency this pump is capable of. So if I were to start the pump, you can see I am stopped locally. That hand tells me I'm stopped locally. start button will start the pump, and I'm currently pumping at 200 strokes per minute. We're going to locally stop the pump. You can see I'm in manual mode, and you'll notice that this Gamma X pump does display the pressure readout of what the pump is currently injecting into. The main screen, we can switch between different displays. So we're at 200 strokes a minute. I rotate the wheel. Our stroke length's 100%. We have the time there, and if I keep going, we go to strokes per hour. So strokes per hour, strokes per minute. I can change any of these by clicking the wheel in, rotating the wheel to decrease that, and then I need to confirm this. If I let it sit, it will go back to that 200 strokes per minute. So I'm going to confirm that. You can see I didn't click it quick enough. So we'll go back to 96. And let's check to see what our strokes an hour. You can see this number also changed to reflect that change that was made in the strokes per minute. I can go to our stroke length, and I can also change that manually here. Click the wheel to confirm that. What I want you to look at here is right now you can see there's 4 different dots up there that are cycling through. We're seeing 4 different pieces of information. We're able to manipulate the stroke length and the frequency right here on the screen. Just keep that in mind for when we change some options on. We also have this secondary menu down here. Right now it looks like that is our stroke counter, so if I start the pump, you can see that. You can hear the pump actually stroking right now, and you can see that number climbing, counting each individual stroke. I'm going to stop the pump. Now if I hold the wheel in, it will initiate that bottom screen, and now you can see I have 10 to 15 different pieces of information I can display. So to run through them, this is our current strokes per hour. We're not running right now, so it's not going to display anything. I turn the pump on. It's going to tell me that, and I go to minutes. You can see that's being displayed. I stop the pump. We're not doing anything, so it's not going to display anything there for strokes per hour or a minute. Next we have a gallons per hour, what the pump's currently set at based on our stroke length and frequency. We have our stroke counter. We have our totalized gallon that the pump has outputted since I reset it. We have our stroke length. Remember, we put it at 63%. We have our, we're able to, and we'll talk about it more, able to manipulate how we control the solenoid in this, so we can have the pump either discharge slow or do a slow suction stroke, and we'll talk about that. That is our current settings for our discharge and our suction. I'm going to go back down there. That's our pressure reading. You can put it down there also. There's our time, there's our date, and then this tells us how our relays are set up. So our relay 1 is currently set up. We'll have to go in and see how it's actually set up. Now whenever I stop and let it set, it will leave that one down there. Once it times out, you can see it just left that one down there. So now when I spin the wheel, I just turn this. To get down here, I have to hold that wheel in to select that screen. What's nice, if I'm sending an analog signal, I can actually pick one of these menus down here to display that incoming analog signal. So I can actually make sure what I think I'm sending from my controller or my DCS matches what's coming into the pump. So that's the main display. Some of these buttons. The top left button is your return button. So if I am in any menus, this is our menu button. So if I'm in any menus, at any point I want to back out, you can see we can go in kind of deep just quickly. If I want to return, I can just back out to the main display. Start stop button, we talked about that. That is going to allow me to either remotely pause, actually locally pause the pump, or to start stop it. So you can see we're locally stopped. So I press this, it starts. Press it, it stops. This is our priming button. So if I hold this in, it's going to initiate a priming sequence. It will take the frequency and the stroke length up to 100%. So I press this in. You can see it started at 10 seconds. I can increase that time up to 60 seconds. It will count down. We'll be priming the pump. If I know the pump's primed, I'm sick of waiting, I can decrease that time with the wheel also, and it will go back to the normal process. If I have the pump running, you can hear it running right now. If I press the priming key, it's going to override what's going on, and you can hear it speed the pump up, and I can increase that time or decrease that time. I do recommend anytime the first time you get this pump in the setup, you have it ready to go. I would, even if you're running at maximum frequency and stroke length up here, I would still use the priming key. When you use that priming key, it overrides some of the stuff this pump's looking for. Remember, this pump is fairly sophisticated. It can detect airlock in the head. It can detect under and overpressure. When we press that priming key, it's going to look past some of that stuff, and it's not going to go into an airlock mode, because most likely there will still be air in that line because we haven't primed it yet. So we'll be pulling hopefully some chemical in, but there will be some air in that line still until we're able to evacuate all that air. So if we press that priming key, it will get rid of that gas before we start going into some errors and try to detect what's going on. We don't want to do that just yet. We don't want it to start looking for some of those things until the pump is for certain primed. So one of the main big features of this pump is up to date. All of our other pumps are sigmas or deltas, the gamma L, the beta pump, the concept pump. This knob was directly attached to the back of the cylinder. There was a physical connection between that knob and the solenoid. That connection allowed us to manipulate the stroke length. Now, if I spin this, you can kind of hear it's freely spinning. This is just a navigation button for me, a wheel, to allow me to navigate through different menus. The advantage that allows us now is there's no physical connection between this knob and the back of that solenoid. There's actually a circuit board on the solenoid, and it has a processor on it that is detecting magnetic fields to manipulate the stroke length now. And we'll talk about that more as we go on. So we'll jump into the menus. I'm going to go through every one of these menus, and we'll kind of jump around, get through some of the easy stuff, and then spend some time on the more complicated stuff we can dive into. This pump can be, like I said, fairly sophisticated. Most of these options you won't need, so you can make it as complicated as you want, or just simplify it and use it right out of the box the way it's set up, depending on each installation. So once I'm in here, if you look to the right here, anywhere you see a black triangle, that means I can dive deeper into that menu. So obviously there's nothing next to end. If I hit end to confirm that pressing the wheel in, it's just going to take me back to the main menu. So let's hit the menu button. Let's go to language. Easy. You can pick different languages. It should come shipped to you if you buy from here in the US. It should come in the English language. There's probably 10 different languages in there you can select from. I'm going to hit the return button to go back. Let's skip up. We'll go to the information. This is kind of your odometer for the pump. This would be for our service technicians. You can see versions. It has a black triangle next to it, so I can go in further. I go in there. It tells me the hardware, software, and the HMI data. That would be for our technicians if they think that you have an older firmware. We would be able to detect that in here, and at that point we can actually email you firmware out to your computer, and then there is a connector. If you were to pull this relay out, there's a connector in there that would allow you to hook up to your laptop and load the newest firmware onto this pump. So that's what's all in there. We can hit the return button. That will take us back a screen. Now in this screen, like I said, this is kind of your odometer. It tells us the time, the date, the max stroking rate. It tells me my serial number, which is real nice. We know with all our pumps, if we look on the side of the pump here, we could see a tag that tells us the serial number. It also tells us the spare parts kit. It tells us a lot about the pump. A lot of times that can be concealed. It may be hard, tight up against the wall or down on the ground. Now I can go in here and I can see my serial number right here. I can pull off to order parts or to order a new one. I can also go down and see the ident code here. Scrolling down, you can see switch on counter. Remember, this pump has a microprocessor in it. It doesn't like to be powered on and off often. Just like your laptop, you don't power that on and off every couple minutes at home. So the microprocessor in this is similar to a laptop. It doesn't like to see those power on and offs. You can see our operating hours are here. Our total number of strokes are there. Our current stroke volume is 1.01 milliliters per stroke. So this is really our odometer to see what's going on within the pump. I'm going to hit the back button. So right there, we've already covered two menus. We've covered the information menu and the language menu. So let's go down and walk through the service menu. Once I'm in here, the first thing you're going to see is access protection. If I go into access protection, it's going to ask for a password. The password on your pumps are going to be the last 4 digits of the serial number. So once I entered that in, it's going to go in and ask me to pick different levels of protection. There's going to be 2 different levels. The first level, if I pick the first level, it will allow me to see what's going on this screen here. But if I click the menu button, it will ask for a password if I pick the first level. On the highest level, as soon as I touch any button, including the wheel, it will ask me to put a password in. So where that's nice is I can now completely lock out the stroke length and the frequency. So in the past, I could lock people out from adjusting the frequency, how often we stroked, but they could still come up and manually adjust this because there was that physical attachment to the solenoid. Now I can lock that out completely. So back into service, access protection were your different levels. If you want to change your password, like I said, from the factory, it should be the last 4 digits of the serial number. If you go in there, it's going to ask for that password. You would put that in, and then you can reset it to whatever you want. Just try to remember that password because it's going to be hard for us to reset. Clear counters. We saw those counters on the bottom of our screen on the main menu. We can clear both of those here, or we can clear them both at the same time. Error log. We can go into error log and we can go look in the logbook. Anytime a certain event happens, it's going to log it here, and we have a list of each event. So we know event 09. I can tell you event 09 is I started and stopped the pump and then it was gone. So that is starting and stop the pump there. If I don't necessarily want to see those, I can filter what events I want to see. So the events would be me starting and stopping the pump. Your warnings would be your level switch, your air lock, your P+, P-, which is your under and overpressure detection. And we can eliminate some of those by going through those filters. Diaphragm replacement is a pretty unique menu for this pump, and I want to kind of show you something to be aware of if you're out there trying to operate this pump. If you have the pump running, we know the pump is stopped locally right now. If I go back to the main menu, I am stopped locally. So I want to start the pump. So the pump's running. I want to go in, go back down to service. Now I look here, there was a diaphragm replacement menu. That has disappeared because the pump is running. So if I stop the pump, you'll see that menu pops back up. So if the pump's running, you lose certain menus. So if you're navigating through this pump and you think you know what you're trying to do and you just can't find a certain menu, there's a couple other, and I'll try to cover those as we go through. If you can't find it, make sure the pump's stopped locally or remotely if you pause it through the brown and black on the universal control cable. Otherwise, it may not show up. So what does this menu do for me? On all of our other pumps, you typically, to do a diaphragm replacement, you turn the pump on, you have it stroking, you turn the stroke length all the way to 0%. That locks in that shaft on the solenoid. It also presses out that diaphragm all the way so we have something to grab onto to twist it off. Well, because we don't have any physical attachment between this knob and the back, it's hard for us to get it to that change position. So we go to the diaphragm replacement, we go to the change position, and you should be able to hear the pump click. So the pump clicked, and what that is doing is it extends that diaphragm all the way out as far as it can. It also locks it into place. So now I can take the head off and spin the diaphragm on, put a new one back on. Then I would want to go in here, change it to the back position, and I could hear it pull it back in, and then put my head back on and torque it down. So it's a little different process of changing the diaphragm. Same process, we just have to make sure we have the diaphragm in the replacement and then in the back position. That being said, this pump does have to be powered on. If you were to power off the pump after I went into this menu, it would pull that diaphragm back in and make it really difficult for us to change. So what we did when developing this pump, in order to make that easier, if it's in a lockout tagout position, we would have to pull the pump out of there, take it to a workbench and work on it. There's a removable plate at the bottom here that pops, that will slide off for me here. It's hard to do if it's not bolted down. There's that plate off. These mounting holes on here are the same exact pattern as a Gamma L. I'm going to slide it back on. You'll hear it click in. And I could take it to a workbench to do my diaphragm replacement. So let's go back into service. Display, pretty easy. I can change my brightness or the contrast here. I have mine turned really far down in order to be able to see it on the screen here with the webcam. We keep going down. Factory settings, it's going to ask for a password. I put that password in, and I can reset the pump back to factory settings. So if the pump may be acting up, you think it's doing something you shouldn't be doing, a factory setting reset hopefully will eliminate that for you. Real nice, we supply the diaphragm part number and the spare parts kit. Both those part numbers right here, so you can order replacements fairly easy. It's not going to get chemically washed off from the foil tag we put on the side of the pump. So I'm going to hit N. It's going to take us back to the main menu. I'm going to go into the menu, and so we've covered information, service, and language. You'll notice these pumps now all come with timers, which is pretty unique. In the past, timers were something you had to order separately as a different selection ident code. We elected to include those with every pump. I'm not going to cover the timer functions in this video. That would be a separate one. It would take a little bit longer to go in there, but I can essentially set the timer up to do different events. I can also have it activate our relay to open up a solenoid down the line to, say, flush the pump out every Friday before everybody goes home. But that menu will be for a different video. So I'm going to go into settings. That's where a lot of our meat and potatoes is. That's where most of the changes are going to be made, and we'll go in there and show you what to mess around with, what you may not want to mess around with, and what the results are you changing certain things. So settings, first thing off the bat, you see mode. I'm going to go into mode. You can see we're currently in manual mode. What's nice about the Gamma X is, compared to the Gamma L was when I picked analog with the gamma L, it went back to the main screen, and then I had to go back in and set up the analog and make sure we were in 4 to 20 most likely. So what would happen is people would go in, put analog, and then they would think it would be set up correctly, and they would start sending an analog signal to their pump, and it may have been set up for 0 to 20 or 4 to 20. We didn't really know. So with the Gamma X, whenever I select analog, it's going to automatically ask me, do I want 4 to 20, 0 to 20? Do I want to do a curve? Do I want to scale that 4 to 20 coming in? And I can also do a lower and upper sideband, for instance, for pH neutralization. You can see my red light came on up here because I selected analog and I have 4 to 20 selected. So the pump is looking for a 4 to 20 signal. Remember, I don't have anything coming down into my universal control cable, so we have something below. We have 0 milliamps, which is below the range of 3.89, I believe it is, where we start seeing a warning of having a incorrect analog signal coming in. So I'm going to accept that, go back to the main screen, and you can see it gives us a warning there. Our current is less than 4 milliamps. I can accept that, but it keeps coming back because it keeps seeing that it is. So I'm going to go into mode again, so settings, mode. I'm going to go back to manual. So remember, we were talking about, we see 4 things here right now. The strokes per minute, strokes per hour, the stroke length, and the time. A unique feature of this pump, if I go into settings, you see automatic here. If I go into automatic, automatic is actually one of the menus that disappears if the pump is starting to stop it. So I'm going to start the pump. You'll see automatic disappeared. Let's stop the pump, you'll see it appears again. So I'm going to turn automatic on and show you what that gets us. So automatic's on. We'll accept it. We're going to back out to the main menu. And now you can see if I spin this wheel, I only get 2 selections now. I get the time, and I also get, it says gallons per hour. So now I can no longer see what my stroke length is or what my frequency is. All I can adjust is directly in gallons per hour what I want the pump to output. So I can accept 1.23, and now the pump will output 1.23 gallons an hour. It will pick the best stroke length and frequency combination for me. So I no longer have to figure out, all right, where do I want to run on my stroke length and my frequency? I don't want my frequency down too low, but I don't want my frequency up too high and my stroke length down too low. This is going to, when the pump was programmed at the factory, it has all the algorithms in it. It knows exactly what the best dosing profile looks like, and based on these conditions, your gallons per hour, it's going to match those, the frequency and the stroke length up for you. So even if I turn on this menu down here, you can see there's less selections down here. I don't even see the stroke length or frequency down here because the pump doesn't want me to know that. And it will always be changing those based on different conditions it sees in the system. So where else this is nice is if I go into, if I were to put it into analog mode, now my 4 to 20 is no longer, typically if I'm out of automatic, my 4 to 20 will be just adjusting. 4 is going to be 0, 20 is going to be that 200 strokes per minute. Now if I'm in automatic and analog's on, I can now, 4 is going to be 0 gallons per hour and 20 is going to be the maximum capacity of that pump. So it gives me a much larger turn down when it comes to sending an analog signal to this pump. And I can also even scale that 4 to 20. So I can have 4 be 0 gallons an hour and 12 be the maximum capacity of that pump. So there's a lot more leeway in manipulating the pump being able to go into that automatic. We can also do an automatic batch. So if I go, and what memory is I'm going to initiate my batch signal from my universal control cable or from the button here on my screen. And if I have a batch going, say I want to do 1 gallon, and I wanted to do that in an hour, I initiate that batch. It's going to take an hour for it to do that gallon. If for some reason I tell it to do another batch and it's still doing that first batch, this memory, if I have it turned on, it will remember that batch I sent to it while it was already doing one. And hopefully that first batch ends and it will start that other batch right away. It will remember up to, I think it's 9 million different contacts coming into it. Hopefully it will be able to make them up. It has time to make that up before the pump times out with that memory option. If I have it off, like it is now, if I'm doing a batch and I send it to do another batch while it's already doing one, it won't do that one. It doesn't remember that batch for when it finishes up. We'll leave it off. Now it's going to ask me, all right, what is my metering volume required to do? So let's say we want to do 1 gallon per contact, so that would be initiation of the batch. So for every time we tell it to do a batch, we want to do 1 gallon, and it's going to tell us how many seconds do we want it to take that time to do a batch. It won't let me do something the pump's not capable. It would tell me the minimum value is undershot. So if we click this, we're good. We'll go back. You can see if I hit this, it's not a touch screen. I have to press this button. If I press that button, it will initiate the batch. You can see I'm pressing it. It's not doing anything because we're stopped locally. Now we're doing 1 gallon right now, and we're going to do it over 690 seconds. The pump is picking the best dosage rate that would be the combination of stroke length and frequency for us. So I'm going to stop the pump. I'm going to go in my menu, go into settings. I want to go back to manual mode. I also want to go to automatic, and we'll just turn that off for now. You can see I can adjust my stroke length here, or I could just as easy do it on the main screen. So let's go into metering. Metering has a lot of good information on it. If I go into discharge stroke, typically I would say you're most likely going to want to just leave it on optimal. We recommend the optimal mode for the discharge stroke. We do have some other options. Fast mode would be doing that, and there's the profiles that kind of explain what each one of those modes does for you. Fast mode's going to do as quick as we can a discharge stroke as possible, possibly used in maybe filling situations. We're trying to fill containers real quick. Next one comes, fill it, just continuously doing filling operations. Sinus mode is a sinusoidal mode, so it is going to ramp up the pump real nice and gentle into there. It's not going to give you real quick bursts of discharge. Continuous, if we're running the pump in a really low turn down application, continuous mode may be a very good idea. It's going to allow us to do a continuous discharge stroke, and I'll give you an example here. I'm going to accept the continuous mode. Sorry, I picked the wrong one. Continuous. I'm going to back out to the main menu, and I'm going to turn this way down. So 1 stroke a minute, and I'm going to start the pump. And you can see the graph. We're doing a discharge stroke right now, and you can see that graph right now. So to give you an example, if I have this on 2, so if I have it on 2 strokes per minute, I'm going to do a discharge stroke for 30 seconds. Let's see, it'd probably be more like 29 seconds because we have to have time to do a suction stroke. We're going to do a suction stroke real quick and then do a continuous discharge stroke for 30 seconds. After 30 seconds, suction stroke real quick, discharge stroke over 30 seconds. So instead of putting slugs of chemical, if we have this in normal mode, so if we turn it to metering, we turn it to the optimal. So we just did one stroke right there. Now we're waiting 29 seconds to do another one. Nothing's going into the process right now. You can see this light is flashing just because it is on. You wouldn't want to see every other flash there. So it's going to do it every 30 seconds. There's nothing going to the system. We may have large amount of water passing by untreated. If it's a batch application, this probably isn't. It just stroked again, so we're waiting 30 seconds to do another one. If it's a batch application, this may not be a problem, but if it's a once through application, you're not going to get the mixture you want. So we would probably start thinking about putting it into that continuous mode. So I'm going to go back in there. I want to put it back into continuous. I'm going to go back. I'm going to change this up. You can see when I'm at 93, it's not really doing anything on the continuous stroke because it has to fit those certain amount of strokes in. Once we start turning it down, you'll start noticing it. That graph shows up representing that discharge stroke. I can tell you I'm going to pause the pump. I'm going to turn this all the way down to 1. Click it. That gives us 60 strokes an hour. I'm going to click that. I can turn this down. I can turn it down to 1 stroke an hour. Now I'm going to start that. The pump is actually doing 1 continuous stroke per hour. So the turn down on this is huge. I don't know if I'd necessarily recommend you turn the pump down this low. On this pump, where the diaphragm is traveling 1.5 millimeters, I believe, a full travel, that is somewhere around a 1/16 of an inch. So it's doing that 1/16 of an inch over an hour. We have had this in a lab setup where it was under ideal conditions doing water, and we were able to get repeatable measurements out of this low of a stroke rate. But again, that was in a laboratory. That was where it was in ideal conditions with water. But I can still turn this up to a couple strokes an hour, and I would be comfortable saying that you're going to get repeatable results at doing that much of a turn down. So you'll notice if you look at the capacities of our pumps, we don't have as many capacities as we did with the Gamma L. The reason for that is because our turn down is so much more greater than the Gamma L that we can get away with not having as many models. I'm going to stop the pump, go back into settings, go to metering, go into here, and again, most likely I would recommend you stay with optimal. The pump will leave in optimal, so most likely you won't even have to go into these menus and mess around with them. That's our discharge stroke. We're going to go into our suction stroke, and we have different suction stroke modes. So we were working on normal. You see HV1, 2, and 3. Those are for high viscosity chemicals that are more viscous than normal. If you look in the manual, I don't have it in front of me, but there's different ratings. It will tell you that if the pump is at 50 centipoise to 50 to 75 centipoise, use HV1, 75 to 200, use HV3, and then from 200 up, use HV3. I'm making those numbers up right now. I don't have the catalog in front of me, but they're listed in there, and they tell you when they recommend to use different HV modes. One thing you have to be careful with if you are using HV modes is that when you manipulate the suction stroke, it is going to limit your capacity of the pump. So we know on normal, I'm going to click normal, go back to the main menu. You'll notice that the maximum I can get out of this pump per minute strokes is 200. All right, that's in normal mode. So I'm going to go into settings. I'm going to metering. I'm going to suction stroke. I'm going to pick HV1. So pick HV1, go back to the main menu. You can see it's limited my capacity to 160 strokes per minute. So HV1 is 160. HV2 is going to limit me to 120 strokes per minute, and HV3 will limit me to, I believe, 80 strokes per minute. We can see. So metering, suction, HV3. I'm going to go back, and I'm limited to 80 strokes. I can't adjust that. So if I decide I need to run my pump in HV3, another thing we're going to use is a high viscosity liquid end. That's going to give us bigger valves. It's going to give us springs in there. If I'm running an HV3, my pump is dramatically cut more than half the capacity if I use in this. So if I manipulate this discharge side, it's not going to affect my capacity at all. If I manipulate my suction side by putting in one of these HV modes, you need to keep in mind that it will derate the capacity of the pump. So I'm going to go back, metering, HV. It will ship in normal, so leave it on normal unless you think you have something that's viscous, maybe a polymer or something. If you can figure out what the viscosity is, you can then go in the manual and it will tell you, recommend you which HV mode to use based on your viscosity. So we're leaving it normal. Pressure rating. This is a pretty unique setting. So we remember this pump can detect overpressure or underpressure. So if I'm pumping into 150 psi, all of a sudden somebody shuts a valve somewhere, my pump has to work harder. This pump is continuously monitoring the energy profile. It knows how much pressure, how much energy it takes to pump into 150 psi. If all of a sudden somebody shuts a valve, my pump needs to work harder. It's requiring more energy to pump against that. The pump will go into a P+ error, which is an overpressure error. Along the same lines, if I'm pumping and I'm pumping against 150 psi, you would be able to get that readout on this screen. It would tell you 150 psi. If for some reason a forklift came by and punctured my line, it would be really easy for me to pump. And at that point, I would go into a P- pressure, which would be a under pressure of loss of pressure. So we were in settings, we were under metering and pressure rating. So depending on which pump you have, my pump is only rated to 2 bar. But if I had, say, a 1602, which is rated for 16 bar, I would have a couple different options here. I would have, I believe, 16, 12, 10, 7, 4. You would have numerous different options. So I would be able to limit the amount of energy the pump could produce. So even though my pump may be rated for 232 psi, I could make sure that it never achieves enough energy to create more than 100 psi. Where that comes in nice is some of our tubing, some of our polyethylene tubing is only rated to 100 psi. I've seen cases where people don't have pressure relief valves on the system, and they go in and they overpressurize, and that chemical ruptures that line and it's shooting all over the place. So now I can possibly get away with not having a pressure relief valve on the system because I can go in here and limit the amount of energy. I would still strongly recommend you have that mechanical pressure relief valve in the system, but this will give you at least a double redundant backup on here. Again, my pump is only rated for 2 bar, so I don't have any other selections. If you have a larger pressure pump, you would have numerous different selections you could pick in this menu. So if you are getting what you believe are faulty P+ errors, maybe go in here and see what it's set at. So if I have a pump that can do 232 psi and it's P+ing at 100 psi, maybe I have this on 7 bar instead of the higher bar rating. So next is the monitor screen. I can go in there, and remember I said this pump can detect airlock. So if I detect airlock, do I want to get a warning or an error? Those would activate my relay card I have installed to send a signal out if I have airlock. If I have overpressure, what do I want to do? A warning would shut the pump off. A warning is going to be a yellow light. Sorry, a warning is going to be a red light. If I have an error, that is a yellow light. The pump will continue to pump, but I'll get that signal out. And then an error plus a warning, I would go into an error with the yellow first. If that overpressure continued to stay there, I would then go to an error and shut the pump off. I believe the pump leaves from factory on warning. We would most likely, if we're overpressurizing the system, want to stop the pump from pumping. I'm going to go back. No pressure, so if we lose pressure, what do we want it to do? Typically, this is going to leave inactive because a lot of our pumps may be pumping into atmosphere out there or no pressure. So this will go into inactive, but we can change it to any one of those like we could on the overpressure. Cavitation, if the pump detects cavitation, we can have it send us a message either. It can give us a warning and let us know that's going on. So the pump is monitoring for cavitation on the suction stroke, and then on the discharge stroke, it will be monitoring for the airlock. So those are those options. These are error messages. If I have it in a warning or an error, it will shut the pump off or keep it running and let us know. And we would either have to come down and if we'd a relay would tell us what that condition was, we would come down and we would acknowledge it from the screen. So that's monitor. Compensation. So if I go into here, it's going to ask me to turn it on or off. What compensation is, remember we have a pressure readout on the screen, and we know that if our pressure changes, so if our pressure increases and it doesn't increase enough to trip the P+, because we're not at that range, say we're at the middle range of the pump, and our pressure increases 20 psi, the pump's going to have to pump more chemical to keep up with the setting we had. So if we turn this on, it will compensate for pressure swings. So if we get more pressure or less pressure, it's going to adjust your stroke length and your frequency to compensate to maintain that flow we asked for to output. We have ours currently active. This is something that goes on in the background. You won't be able to actually see the pump compensating. You may be able to hear it when the pump is running, if the pressure swings are there. Ideally, I would recommend you have back pressure valve on the system so we maintain a consistent back pressure on the pump in order to help with repeatability. But if not, this compensation option will obviously help our metering accuracy by being able to compensate for those swings. So that's everything we have in the metering menu. I'm going to hit back. We have a calibrate menu just like we would in a gamma, L, delta, and a sigma. You would go in there, you would have a calibration column, and you would have it filled, go through the calibration. It walks you through that process. I will tell you this, with we saw automatic on, you were able to adjust just in gallons per hour. The further away from I get from water, the more you should start thinking about calibrating the pump. It's a good idea to calibrate the pump no matter what. Remember, we're trying to very accurately meter with these, so we want to know what effects some of our piping has on the capacity of the pump. Remember, there's some exterior things that are going to, there's certain conditions that are going to change the capacity of this pump, whether it be tubing sizes, elbows, any restrictions in the line. So we want to do an actual calibration to see what our pump is actually outputting. So system, we see system here. If I start the pump, you'll see system menu's gone. So the system menu is one that disappears if the pump is running. So I'm going to go into the system menu. You'll notice that I go into here. So what's unique about this pump also is I can change if the pump I decide down the road I want to do a different chemical, so I need a different liquid end, or if I need a different capacity, I can look at the charts and change the head. I would buy a spare parts kit with the head complete, equip the pump with it. I would go into this menu and assign that pump to this, and it would change that energy profile that the pump would be looking for. We can now do that with our deltas, sigmas, and the gamma X. We can change to any head in the field. I will tell you that there are 2 solenoid sizes in the gamma X, so you're limited to switch in between the 2 solenoids. You can't pick a head from the larger solenoid and put it on the smaller solenoid. It wouldn't work out, the capacity rating there. If you look at our chart, you'll see that the smaller solenoid is the top few. You'll see the capacity in gallons per hour going up, and I believe it goes up to 5 gallons an hour. And then you'll see the next one below it jumps down to like 1 gallon per hour. So you'll see the capacity go up, and all of a sudden it drops back down. That is where the separation of those 2 solenoids are. So I want into no dosing head. Let's see, we're in settings. We're in system. We're in dosing head. Just looking right now, you'll see I have no, so it's asking for self-degassing. We have a couple different options. I'll explain those, but I'll show you mine is set up for no, and it's set up with no dosing head. I will recommend that if you're doing a demonstration to where this pump isn't under chemical, you don't have water running through it, if you don't have it under pressure, I strongly recommend, if you're trying to do a training or a demonstration like I am here, I would recommend you go in here and turn this to no and this to no. That will eliminate it looking for that overpressure, under pressure, that airlock, because the pump can sit here and run dry. It's not going to hurt it doing that, but you'll get errors. You get a whole bunch of faults, warnings, because the pump is trying to do what it's supposed to do. If I'm sitting here dry, there's obviously air in the head, so it's going to give me airlock errors. So in order for me to eliminate that and to not have that jumping up all the time when I'm doing a demonstration, I can do that, and it's going to bypass all of that warning system. But going back, so self-degassing, I just have a Teflon head on this, but if I had our NPE, our acrylic head with the 3-valve option, you would pick ball. If I have our new PVT7 head, which has a special groove in the discharge seats, I would pick groove. Stainless steel, I would pick steel. That only thing that changes is some of the pressure ratings you can pick. But one thing you need to keep in mind, if I pick either the ball or groove, I lose my automatic. I can no longer use the automatic option on this pump we were talking about earlier. The reason for that is we can't account for our loss of air, how much the chemical's off-gassing. So if we're doing bleach, we can't calculate how much that's off-gassing. It's going to change based on the quality of the bleach, the temperature outside. So we can't set the pump for 1 gallon and it's going to do that 1 gallon because we don't know how much we're losing through that vent. You lose that automatic with ball and groove. You also lose the pressure readout. So the pump will no longer at the top right give you the pressure readout if you have, if you're familiar with our ident codes, it would be an NPE9 or a PVT7. So it would be that 3-valve or the Kynar head with the slotted seats. So keep that in mind. I'm going to leave mine at no because I don't have any degassing options. And then this pump would be, if I look at the tag on the side, see if we can get you to see it. This tag tells me it is a, I don't know if it's clear, it says it's a 1009 So I'm going to go down and I would pick 1009. And I would select that. I'm not going to do that because I'm still, for demonstration purposes, leaving it at no dosing head. Volume, pretty simple. If I go into here, that's where I pick gallons per hour or liters. Here's where I'm going to pick PSI or bar. Pretty simple. Hit the back button. Pressure adjustment. We set this here at the factory, but if your pressure gauge, you should always have a separate pressure gauge on the system. If that pressure gauge is reading something separate from what's on the pump, you can go in here. It's going to ask for a password. Remember the last 4 digits of your serial number. You put that password in, and while the pump's running, you just match up the PSI on your gauge to what's on here. And that will it's a calibration process for that gauge. We do that here with our programming and on our test stand, so when it gets out there, most likely should be accurate. I would recommend that you let it run for maybe a couple hours before you go in there and do it. It may need some run-in time to adjust those, to see what's going on in the system before it matches up. It should gradually match up with your system pressure. I'm going to go back. That's your system menu. So we're going to continue to go down. We have a couple more options. Inputs and outputs. So when I go into here, you'll notice auxiliary frequency. Auxiliary frequency, if you're familiar with our universal control cable, the orange cable, 5 wires, there's a gray wire on there. Probably not very commonly used, but if you were to short that out between the brown and the black, that overrides your manual setting on the pump or your analog signal coming in. So it's an auxiliary frequency that overrides that. On prior pumps, the only thing we can manipulate with that auxiliary frequency is we could only adjust the strokes per hour. So right now, if I connect that gray wire to my brown and black, it's going to ramp the pump up to the maximum stroking rate. Because our pump is no longer directly attached with this knob here, we can also change the stroke length. So that's something unique. Going down, you have your different relay options. So relay 1, you can see we have a fault indicating. So if you were familiar with our DENT codes, we have a C relay. So we have a fault indicating relay and a milliamp output relay. From the factory, they come set up. We'll see how this one is. They usually come just as timer, which isn't very common. So whenever you get your pump and you plan on using a relay, you're going to want to actually set the relay up. So we're going to go to timer and say we want a warning or an error. So we can have error, warning plus error, pump active, and a cycle count and a stroke rate. So if we go to warning plus error, we go there and then we pick whether we want that polarity to be normally open or normally closed. So you can pick between those. In the gamma L, we had to pick whether we wanted the relay to be a normally open or normally closed, and it was programmed that way. This one, we can go in here and program it whichever way. We can switch in between energizing or releasing. So we go to milliamp output. We'd probably want a 4 to 20 output, and we would probably want to do liters an hour. And it's asking us at what is 20 milliamps, so we would have to look to see what our maximum capacity of our pump is and put that in there for our 20 milliamps. So make sure you set your relays up when they get out there. Pause input is pretty unique. Here we can, remember our pause input is from our brown and black wire on our universal control cable. We can switch to where we knew in the past brown and black had to be together, or it was in pause. Now we can make it that if brown and black are apart, the pump will run. We can also change our level, warning, and error. That's our level switch, our 2-stage level switch, which goes into this port to either be break or make contact. I think that may mainly for system integrators. Instead of having to call up the PLC programmer, we can now come down here and just simply switch that pause input here instead of having them to reprogram that whole PLC. So I'm going to go back. Degassing. If I go into the degassing menu, I have to, if my pump detects airlock, we can do different things. So I can turn it off. So if my pump detects airlock, remember we set it up here in metering under monitor, airlock, we have it, we can set it to say warning. So if my pump detects airlock, it's going to give me a warning, a yellow light up here, but it's not going to do anything about that. So what I can do now, if we go back to the degassing menu, is if I detect airlock, I can actually have it do something. So if it detects airlock, it's going to go into a degas mode. So that degas mode, what it's going to do is pause the pump for 1 second, and then it's going to ramp up the pump to maximum frequency and stroking rate, and then it's asking me how long do I want it to do that for. So I want it to do that for 10 seconds. So now my pump's set up so that if it detects airlock, it's going to go into airlock mode and go up, ramp the pump up the most it can, and try to evacuate that air out of there. So it's going to pause, ramp up for 10 seconds, stop. It's going to go back to what it was doing. It's going to be monitoring. If it's still airlocked, it's going to go back into that mode for 10 seconds, and it will do that 3 times. After the 3rd time, if it still is sensing that airlock, it will turn the pump off. There's no point. It's going to go into a error. It's going to turn the pump off and give you a message. Periodic is, I can set it up so that every 34 minutes I want it to go in that cycle for 10 seconds. So every 34 seconds it's going to go into a degas mode. Even though it's not detecting it, it's going to go into that mode to hopefully prevent that from happening. And then both would be a combination of the periodic and airlock. So if you're doing something that off gases, I'd recommend you go here and set that up. Otherwise, if you're not doing a chemical that off gases, you don't need to mess with this menu. Priming time, we showed you how to change that on the main screen by using this button. I can also go in here and just set it for 60 seconds so that every time I hit that button it goes up to the max instead of 10 seconds like it was set up for. Set time, you can go in there and depending on where you are, you can change the date, whether or not you observe daylight savings time in your area, you can turn it on or off there. You can tell it when summer ends. There's a whole bunch of different things you can manipulate in the date and time. Most likely, you won't have to go in there. I would say if you're using the timer function, you're probably going to want to go in there and make sure the time is set up correctly. Then you can also do the date there, pretty simple. We're going to go back to the main screen. We're back to the main screen and we're ready to run manually here to do what the pump is doing. You can see I have an airlock here. Remember, we turned that airlock on, so the pump obviously is sitting here on a table, no chemical running through it, so it's doing what it's doing what it's supposed to be doing. You can see it tried to do it for 10 seconds. Now it's going back to what it was doing. Let's stop the pump. So that was going over all the features of the pump. It was a lot of information. Hopefully this makes you a little more comfortable with the pump. If not, please feel free to call into our technical support so we can make sure that you are comfortable with programming this pump and going through each of the menus. Remember, it only needs to be as complicated as you want to make it. Usually the pump out of the box, most of the settings are picked for you that you should be able to just run. And then those menus we went through would be to fine-tune things. So thank you for joining me today, and I hope you can take this and apply it to your next startup of your Gamma X.